Alright, ladies and gentlemen, welcome back to your video notes for Algebra 2. This is for your McGraw-Hill Algebra 2 book. We don't do all of Chapter 5, so here in 5-4 we're talking about using synthetic substitution to evaluate a polynomial function, and then we will turn around and graph using those skills. So this video is probably going to be the longest of the three that I'm recording today because these problems require a fair amount of work. Essentially what we're going to do is we are going to plug these x values into the function using synthetic substitution, which means we need to run synthetic substitution a number of times. I mean, there's 7 points there that we were asked to find on this t-table. Now I will say we don't have to do them all because there is one here that we're never going to have to do, and that is x equals 0. Because when x equals 0, all of the terms of this polynomial drop out except for the -3. So in this case, when x equals 0, y has to be -3. So we don't need to do much work there. We just need to make sure we realize that that means the point 0, -3 is on our graph. So from there, what we're doing is we're taking each of these x values individually, such as -4. We're placing them into the box, and we are running synthetic division like we saw in the last video on this function. So the first number comes straight down. -4 times 1 is -4. Add down would be -1. 4 times -1 would be +4. Add down would be 3. -4 times 3 would be -12. Add down would be -15. What that means is that when x is -4, y is -15. I know what you're thinking, that's not even on our graph. Why would we bother with that? Well, the way that we approach this in this course, when I give you that table, what I'm giving you is a range of x values that are going to fit on the graph plus 1 point on each end. So what that tells us is that at -4, our graph is below what we've got available for us to graph. We'll talk about that more in a minute. So we move on to -3, and we run synthetic substitution again. Bring the 1 straight down. -3 times 1 is -3. Add down is 0. -3 times 0 is 0. Add down is -1. -3 times -1 is +3. Add down is 0. Which means when x is -3, y is 0. Then we do -2. You'll see how this process is just repetition. All we're doing is repeating over and over again synthetic division. -2 times 1 is -2. Add down is 1. -2 times 1 is -2. Add down is -3. -2 times -3 is +6. Add down is 3. So when x equals -2, y equals +3. -1 goes in the box. 1, 3, -1, -3. And we run synthetic division. 1 comes straight down. -1 times 1 is -1. Add down is 2. -1 times 2 is -2. Add down is -3. -1 times -3 is +3. Add down would be 0. So you can see how we're filling out the chart 1 point at a time by using synthetic division. 1 would be next. 1, 3, -1, -3. Bring that 1 straight down. Multiply, add down, multiply, add down, multiply, add down. So 1 is a 0 as well. Okay, this is the process we go through. We simply go through and we are going to run synthetic division for all of these values. So I ran out of space here, so I'm going to write this one a little bit smaller here on the inside. We're going to run 2, 1, 3, -1, -3. Okay, so we're just going to run synthetic division 1 time for each of the values provided to us in that t-table. So when we get done doing that, that's 18, so we have 15 for that point. F of x here is what's called, y here is what's called a cubic equation. It kind of looks like a pair of parabolas that have been attached to each other. Okay, it should have one of 2 shapes every single time. Okay, it's going to look like one of these 2 things every single time, like 2 parabolas that are attached to each other. One end of it will always point up, the other end will always point down. So if we graph the points that are on the graph, we're looking at -3, 0, negative 2, 3, negative 1, 0, 0, negative 3, 1, 0, and the rest of the points, 2 were off the top of the graph, negative 4 were off the bottom of the graph. So what happens is the graph enters from the bottom between negative 3 and negative 4. It passes through these points in order from left to right, and it exits again before it gets to positive 2. Now what that tells us is this. We are able to identify the solutions of this graph because they are the values where y equals 0. Remember that there are 4 words total that mean solutions. The other 3, other than solutions, are the roots, the zeros, the x-intercepts. All of these mean the same thing. So if we look at the graph, we can easily identify the x values where this graph crosses the x-axis. They are x equals negative 3. Again, that's right here. X equals negative 1, right there. And x equals positive 1, right there. So that's how we approach these problems. We run synthetic division one time for each x value in the table. We graph the points that actually fit on the graph. The top and the bottom point will tell us whether we're off the top or off the bottom of the graph. We draw the graph and then we identify the x-intercepts as being the solutions. So let's do, there's 3 more of these. We're going to do another one together and then I'm going to ask you to pause the video and try on your own. So here's example B. Again, the process is relatively simple. We're going to take each of those values in the table and we're going to run synthetic substitution. So we put negative 3 in the box and we pull the numbers off of y. Bring that negative 1 straight down. Multiply by negative 3 is 3. Add down would be 5. Multiply by negative 3 would be negative 15. Add down would be negative 10. Multiply would be positive 30. Add down would be positive 24. So at negative 3, we are off the top of the graph at the point 3, 24. Negative 3, 24. Negative 2 goes in the box. Same numbers for synthetic substitution. Okay, I screwed that last one up pretty good, so let's erase it and try again. Okay, and we're running through that process. So we bring that negative 1 down. Multiply would be positive 2. Add down would be 4. Multiply would be negative 8. Add down would be negative 3. Multiply would be 6. Add down would be 0. So negative 2, 0. Then we run it with negative 1. Okay, again, this is the process. We run through the same synthetic division problem with each value in the x column. So bring that first number straight down. Multiply. Add down would be 3. Multiply. Add down would be 2. Multiply. Add down would be negative 8. Remember that we do not need to do synthetic division for 0. You could, but you don't need to, because the last number, the whole number term, tells us when x equals 0, y equals negative 6. So as long as you know that fact, it'll save you one round of synthetic division. Then we continue on to the next one, which would be positive 1. 1 comes down, multiply, add down, multiply, add down, multiply, add down. Okay, so what did I screw up? Oh, that's supposed to be negative 1. All right, so that's, I knew that something went wrong because it shouldn't have crossed unless it was a whole number. So let me fix my math there, because that's going to change that problem significantly. Okay, let's try that again. Bring that negative 1 straight down. Multiply by 1 would be negative 1. Add down would be positive 1. 1 times 1 is 1. Add down would be 6. 1 times 6 is 6. Add down, we should have had 1, 0. 2 goes in the box. Your numbers go there. I'll be a little bit more careful to not screw it up this time. Negative 1 comes down. Multiply would be negative 2. Add down would be 0. Multiply would still be 0. Add down would be 5. Multiply would be 10. Add down would be 4. So 2, 4. I'm going to move up here and put 3 in the box up here, but again, we're still just running synthetic substitution with those same 4 numbers. -1 comes down, multiply, add down, multiply, add down. So I screwed something up again. That's -3. Come on, Wills, pay attention, man. It's been a long day, folks. I apologize. Stepping back, 3 times -1 is -3. Add down is -1 is -3. Add down is 2. That's 6. So that should be 0. And then we don't expect 4 to be useful. Okay, it's probably not going to be on the graph because it's the last point in the table. But we need to know what the graph is doing. So we need to know whether it's off the top or the bottom of the graph. So we're looking at a value there of -18 when x equals 4. Okay, we graph the points that we have available to us, which are -2, 0, -1, -8, 0, -6, 1, 0, 2, 4, 3, 0, and then we need to keep in mind that at -3 we are not on the graph, we're off the top, and at +4 we're off the bottom. So this graph comes in, passes through these points, and exits out the bottom. Not my best graph, but we'll run with it. Okay, then we need to identify our x-intercepts. There are 3 of them. It crosses the axis at 3 places. Those 3 places can be seen in the table. They're the places where y equals 0. So those 3 values are x equals -2, x equals 1, and x equals 3. Remember, we're looking at the x-intercepts, the zeros, the roots, the solutions. Okay, they're all the same thing. All right, there's 2 more of these. So what you should do now is you should pause the video and try these on your own and then resume the video to see how you did. I am going to go quickly through these 2 examples to try to keep this video relatively short. All right, so hopefully you've tried it on your own. We're going to put -6 in the box. Our coefficients are 1, 9, 23, and 15. Again, we don't really expect this first one to be all that useful to us because it's mostly just telling us how the graph is behaving at -6, which is it is below, it is off the bottom of the graph. This next one, however, we would expect to be useful. If 2 of them in a row were off the bottom, we'd have reason to be concerned. So we do 1 comes straight down, multiply by -5. Add down would be 4. Multiply by -5 would be -20. Add down would be 3. Multiply by -5 would be -15. That is a 0. Plug in -4. 1, 9, 23, 15. Bring the 1 straight down. Multiply, add, multiply, add, multiply, add. We're looking at -4, 3. -3 goes in the box. Same deal. First number comes straight down. Multiply, add, multiply, add, multiply, add. And we get -3, 0. -2 goes in the box. 1, 9, 23, 15. You see the process by now? So we just run through this thing here. We get -3. -1 goes in the box. Run it again, and we get a 0 for -1. And then, as I mentioned before, we do not need to do 0 because 0 is 15. When x equals 0, the y value equals the constant term 15. So we go through and we graph those points. We got -5, 0, -4, 3, -3, 0, -2, -3, negative 1, 0. And then by the time we get to x equals 0, we're off the top of the graph. So we come in from the bottom, pass through those points, and exit off the top before we get to the y-axis. Once again, it should be relatively simple for us to identify the solutions, because solutions is the same as the word x-intercepts. It is the three values where the graph crosses the y or the x-axis, which means where y equals 0. That would be x equals negative 5, x equals negative 3, and x equals negative 1. Remember again, x-intercept. It's the same as solutions. Okay, last example. We'll see if we got anybody with this, but the first thing we need to realize is if we're doing synthetic substitution, we need to add a 0 to the end because we have to have every term, which would include that numeric term. Okay, so we're going to run through this again. Again, we don't need to do 0 because 0 is the constant term. So we know that this graph is going to pass through 0, 0, because when x equals 0, y also has to equal that constant term 0. So we're going to run through this. Negative 1 goes in the box. 1, negative 6, 8, and 0 go outside. Multiply, add, multiply, add, multiply, add. And we get negative 15. And unfortunately, my finger dragged a little bit there, and that kind of looks like 16. Let me see if I can get that cleaned up without making too big of a mess of things. Okay, those are 15s. Don't need to do 0, so 1 goes in the box. We run synthetic substitution, bring it down, multiply, add, multiply, add, multiply, add. We get 3. Put 2 in the box, synthetic substitution. Okay, we've done a few of these now. We shouldn't need much. Okay, hopefully you're not skipping too far ahead when you go to skip here. So 2, 0. Three, negative 3. Bring it down, multiply, bring it, add down, multiply, add down, multiply, add down. We get 4, 0. And then we don't expect 5 to be useful, but we're going to do it anyway. I expect to see that work. 1 comes down, multiply, add down, multiply, add down, multiply, add down. Looking at positive 15. Graph what points we have, which are 0, 0. 1, 3, 2, 0, 3, negative 3, 4, 0. We're coming in from the bottom at negative 1, we're at negative 15, so we're coming in, we're passing through those points, and we're exiting off the top before we get to 5. So again, the solutions are the x-intercepts, which are shown clearly on the graph. They can also be seen in the table. So our answer, our x-intercepts, our solutions, our roots, our zeros, are x equals 0, x equals 2, x equals 4. All right, that does it for our 5-4 notes. Thank you very much for your time and attention.